Yes, once again, good morning, all. In the last class, we have seen the concept of DTD, which is meant by document type definition. In three parts, I have defined. I have explained clearly along with the execution, and also we have seen in the last class various lab programs for DTD along with the cardinality concept. And also, we have seen one of the real-time example of XML in the previous class, right? One is I have taken as a Nano website and educate website that will come under a real-time example. Yeah, fine. Guys, while explaining the concept of DTD, 1 minute. Yeah. Yes. While explaining the concept of DTD, I have taken one important point called XML correctness. XML correctness. What do you mean by XML correctness? It should be a well-formed document and also it should be a valid document. Well-formed document means it has to follow correct syntax, meaning that they should be uh, correctly closed, meaning that wherever the open tag is opened, in the same way we need to close that tag. In the same way we need to close that tag. Am I right? Okay, fine. And also it has to follow all the rules, like all the attributes should have to enclose either with double quotations or you have to enclose with either single quotation. Like that we have some kind of rules. I think I have defined 7 rules. If they follow those 7 rules, we call it as a well-formed document. And the document which we call it is a valid when it will follow all the semantic rules. What do you mean by semantic rules? These semantic rules are the rules given by the developer. Like for example, Gnanamu people will ask some kind of data in the form of particular format. That particular format we call it as the set of rules. Those set of rules we call it as semantic rules. All the semantic rules we are going to define with the help of a DTD. We are going to define with the help of a DTD, or I said already we can go for with the help of a schema. We can go with the schema, right? So this DTD part we have already completed in the previous classes. Now I will take the concept of XML schema. XML schema, yes. So which we can simply call it as XSD. XSD. So XSD means XML schema definition. XML schema definition. Yeah, guys, what is the advantage of DTD? DTD means document definition, which is meant for to define the structure of XML document. To define structure of XML document. Sir, what is the purpose of XSD? The same purpose, to define the structure of XML document. Yes, meaning that what is the purpose of defining the structure? In which order, in which format I need to get the data, that we can define with the help of either DTD or XSD. But the most recent latest technique is XSD. This DTD is a old technique and it is not that much powerful. But whereas coming to XSD is a new tool and it is a powerful technique. Yeah, fine. So if you observe some of the differences, the basic differences between the DTD and this XSD, this DTD having very less number of data types. Very less number of data types. Guys, we have seen various kind of data types in DTD. Like for elements, we have seen a data type called PC data. For attributes, we have seen various kind of data types. One is C data, enumerated data type we have seen, ID we have seen, ID reference we have seen, entity. Like this, we have seen various kind of attributes in this DTD. Meaning that we have very less number of data types are available in the DTD concept. Whereas coming to, so as we have very less number of data types, how we have less restrictions. We have less restrictions. Let me explain that in the next point. Yeah. Whereas coming to XSD, we have more number of data types. We have more number of data types. More number of data. Yeah, guys. Observe. So this piece data, if you are going to write like it as a PC data, it is going to allow both integer, float, character, string, etc. All data types are going to allowed by only single data type called PC data. Whereas coming to XSD, we have separate data types for each and every data. Separate data type for each and every data. Like for example, string, boolean, decimal, float, double, duration. Like that, we have various kind of data types are there. So almost we have some 44 built-in data types are there. 44 built-in data types are there. Those are data types are meant for specific purpose. So we have more restriction on the data. We have more restriction on the data. For example, in DTD, if you are going to write like age, if you define like has PC data, the user can enter the data as 31. The data as 31, but generally we are going to enter the data like 31, but our DTD is going to allow 31 also. So this is the reason we can call it as a less restriction. Whereas coming to XSD, we can go for defining it as the age field as integer, then it can allow only the integer value, but it can't allow the 31. It can't allow the 31. So because of that reason, I am saying that is more restricted. And also if you go for in-depth, so if you have clear-cut idea about the cardinality of the DTD, where in DTD we are going to write from 0 to star. 0 to star means itself 0 to n, right? So 0 to n, or we can able to write 1 to n. So this defines star, this defines plus, or we can go for defining question mark, that is either 0 or 1 time. 0 or 1 time, meaning that only 3 possibilities are there. For example, my requirement is I would like to define from 0 to 5. Can I able to write this concept in DTD? No, it is not possible. Guys, if you write like employee star, what does it mean? I can able to allow 0 or more number of employees. That's it. 0 or more number of employees. I can't able to define 0 to 5 employees. That is not possible in DTD. Whereas coming to XSD, we can able to define the fixed number. Like 0 to 5 or 5 to 10. Guys, can I able to define here 5 to 10? It is not possible because we have to use either only plus operator. But whereas coming to XSD, we can able to define many number of constant operators like 5 to 10, or we can define like 10 to 15. So meaning that in DTD we have the generalized structure. Like star plus 0 or 1. That's it, or question mark. Whereas coming to XSD, we can have our own requirement. We can write any number of times. And one more difference is this DTD concept is not going to support the concept of namespaces, and it is also not convenient for to write every DTD by every programmer. I mean, if you would like to write a DTD for an XML file, you have to learn a new language. Like how to write the DTD, all this. Am I right or not? So what you are going to write? You have to write like doc type, some root element, followed by like this. You are going to write. So this is a kind of new structure which is not related to the complete XML file. It's not related to XML file. So you have to write you have to know the new concept while writing this structure of an XML document. Whereas coming to this XSD, it is going to support the concept of namespaces, and also it is the convenient for the programmer to write that structure within the XML file itself. Guys, I hope you already know this concept of namespaces. Namespaces, which is simply a fully qualified name in Java. What is the purpose of this import keyword? Which is meant for to invoke some other functionalities which are developed by some other programmers. Am I right or not? Yes. So at the time we are going to use the keyword called import keyword. Similarly, in XML also, if you would like to import which are written by some other programmers or which you already defined by some other file, then we can go for the concept of namespaces. So these namespaces we can able to define with the help of either XMLNS attribute, or we can go with the concept of prefix. This is what we have explained clearly at the starting of this XML concepts. Okay, these are some of the differences between this DTD and XSD. Okay, fine. See guys, as I am saying that this XSD contains more number of data types. If you go for in-depth about these data types, yeah, fine. In DTD, for elements, we have a data type called piece data. That's it. Piece data. Yeah. For attributes, one of the data type is called C data. Now, if we are defining some data like C data, if you are trying to pass some other special, like except characters or numbers, if you pass any other symbols like question mark, star, greater than symbol, like that, if you pass, it is going to provide an error. So if you practice it, you will get this kind of thing. You will get some kind of data. So at the time we can go for the concept called NM token. NM token data type, meaning that if you are going to write a data type called NM token, it is going to allow character data type, numbers data type, as well as special characters also. That is the thing you have to understand. Okay. So coming to XSD data types. So generally, if you take anywhere data types, it is classified into two types. One is simple data types. Another type is called obviously complex data types. So simple data types which are already developed by some programmers. So those are all, we call it as built-in data types. Like again, if you observe, these built-in data types are again classified into some two types. One is primitive data types. Another one is derived data types, as data structures. Yeah. So primitive data types comes under all the things, like whatever the things that I have explained right now: string, boolean, decimal, float, double, duration, date, time, date, or something like some binary numbers or some notation. All these. Whereas coming to derived data types, which we are going to derive from the primitive data types, all those called derived data types. Like for example, ID, NM token, name, integer, non-native integer, all unsigned short, all this will comes under derived data types. Okay, fine. Coming to complex types. So which data types we call it as complex data types? If it is a combination, we call it as complex data type. Like simple elements, complex elements antam kadamma. Like for example, if you take various kind of XSD elements, generally these are all two types. One is simple elements. Another type is complex elements. Yeah. So we'll go for them again to the next slide. Yeah. First, let me complete these complex data types. So these complex data types can be MTM, meaning that this data type is not going to allow any data. That is what we call it as empty, or it is going to allow some simple content. Simple content means it can be allowed on a plain content like simple text, or it can allow a complex content. See guys, if I am saying that a complex data type as empty, it is not going to allow any data. Not going to allow any data. If I am saying that it is a simple content, it is going to allow only text data. It is going to allow only text data. If I am saying that it is a complex content, it is allowing complex content, that content can be defined in three ways once again. Either in sequence format we can define, or we can define in the form of a choice, or we can define in the form of an all. We can define in the form of an all. Okay, fine. So meaning that complex data type is allowing complex content. That complex content can be a combination of one or more types. Like it can be an element, or it can be a data, or it can be a more number of different formats of data, or anything. That all the things we can able to define in the form of sequence. Meaning that if we are going to specify, meaning that it contains some child elements, right? It contains some child elements. If I am going to define the child elements in the form of a sequence, then we can say that it is a sequence complex data type. Meaning that if I am defining a complex data type, in that if I use a data type called sequence data type, you have to define. See, this is what XSD is meant for, to define the structure. So as I'm defining the structure as like a sequence, in the XML also, whatever the child elements order is there, in the same order only we need to define. Yes, guys, the same concept we have seen in DTD. Yes, in DTD, what we did. So if I define some order, if we didn't define this order in the XML, you will get some kind of error. You have observed, I think, this one. Yes, meaning that if the same property you need to get in XSD also, then you have to use a data type called sequence data type. Guys, so while explaining the example, you can clearly understand. Coming to choice, if we define some elements in the combination as a complex data type, it is not necessary to follow the sequence. The choice itself defines out of all the child elements. You can only define minimum one. Meaning that it is going to allow only one element in the XML file. More than one element, it is not allowed. Whereas coming to sequence, you have to allow all the child elements. You should not cut at least one child element also. Whereas coming to all, it can allow all the child elements, but those can be in any order. Whereas coming to sequence, it has to allow all the elements, but these should be in the order, whichever the order that I have defined in the XSD. Whereas coming to all, it has to allow all the child elements that can be in any order. Whereas coming to choice, it has to allow only one child element out of all the child elements. Yes. As if you simply remember the concept of enumerated type in DTD, that thing we can call it as a choice. Yes, this is what all about brief discussion about the various kind of data types in XSD. Yes, coming to next, XSD elements. How we are going to define the elements, all these things. Yeah, in DTD, how we are going to define the elements? We are going to write like this, right? Attributes, we are going to define like attribute list. Okay, fine. So this is what element declaration, and this is what attribute declaration. Coming to XSD elements, these are of two types as like previous normal thing. Elements are of two types, right? Simple elements and complex elements. So simple elements means which is going to, if you go for writing like this, simple elements, these are going to allow only text data. These are going to allow only text data, meaning that if an element contains text data, which we can call it as simple element. We can call it as simple element. Whereas coming to complex elements, if an element contain, so the definition we should already know. If an element contains a child elements or attributes or a combination of both child elements as well as attributes, then we can call it as complex elements. Complex element. Yes, guys, if you observe the example, I want to give this example after this many number of classes. Employee number 181, closing of employee number. This is called simple element. Complex element means, for example, let me take employee. It contains some subchild. Employee number 181, closing of employee number. That's it. Employee. This is what we call as complex element. Meaning that, so these complex elements can be declared in many ways. So I think I have covered all this also in the previous classes, if you observe somewhere, while explaining various kind of elements. I think, yes, observe content model. All these contains we can call it as complex elements. So if we allow an element with text data and attributes, if you want to generalize here, if you are going to allow an element with text data and some attributes, we can call it as complex element. If you allow an element with an empty content and attributes, we can also call it as a complex element. If you are going to allow an element with child elements along with the attributes, we can call it as a complex element. If you allow an element with mixed content along with attributes, then also we can call it as complex element. We can call it as complex element. Yes. Now here the question is how we are going to define these complex elements, or how we are going to define these elements in XSD. As part of the DTD, we are going to define like this: element name. This structure we have seen, right? Yeah. As part of this XSD, how we are going to define? So the simple structure is, syntax is, we have to go for the element, go for the tag name as element, and we have to define the attribute as name. In that, we have to define the element name, and if it is a simple type, we have to define the type of data type. Whereas coming to that DTD elements, we have to define the PC data if it is for elements. If it is for attributes, we have to define whether it is a C data, NM token, NM tokens, ID ref, all those. Yes. If you go for example, simple example, like for example for simple elements, I can define like element name equal to employee number, and what type of it is, guys. In DTD we are going to write like PC data, we are going to write like has PC data, not PC data. Here we can able to define the int, we can able to define integer, or for example I would like to allow the name. I need to define one more element name is normal name. I mean, let me take employee name. What type of data it is? It is allowing string data. So guys, whereas coming to DTD, here it's also we are going to define as has PC data. Here also we are going to define as has PC data. The reason is it is having only few data types. That is why it is less restricted. Whereas coming to this XSD, it is having more number of data types are there, so that is why it is more restricted, and we can able to define specific type of data type, like whether I am going to allow the employee number as integer or string or what. So employee name is string. Yes, fine. So if you are going to define the complex types, so from here onwards it is important. I would like to define the complex elements. Complex element means it's a nested kind of structure. It's a kind of nested kind of structure. Yes. For example, I would like to define a complex element with the child element. Complex element with the child element. Element with the child element. Yes. First, let me know if I am saying that an element has a complex element. First, I have to define that element. First, I have to define element. Yes. For that, what I will do is I would like to define element followed by element name. Followed by element name. Whereas coming to this complex element type, we are not going to define the type. We are not going to define the type because it implies as a complex type. It implies as a complex type. So at that time, so this way we need to close the element. We are going to close the element. Yes. Or else, if it is normal simple element, we can go for closing here. It's here. See guys, I hope you understood already. If you are going to have like this one, we can simply call it as simple element. But I would like to define it as a complex element. That is why it is going to allow child elements. Child elements. So that is the reason I need to define all the things in between here. In between here, yes. So to define to the parser as a complex type, we need to use a data type called and a tag called complex type. Complex type. Complex type. Yes, okay. Fine. In between now, we can write any number of child elements. In between, we can write any number of child elements. Yes. These child elements can be, observe now, these child elements can be again, guys, as I said already here, you can observe. This complex data type, this can be anything, an empty or simple content or a complex content once again. If I am going to allow empty, yes, I can able to allow an empty one. If would like to allow simple content, I can able to allow simple content. If would like to allow complex content, I can able to allow complex content. But if I am going to allow the complex content, you have to define once again whether it is a sequence, whether it is a choice, or whether it is an all. Whether it is an all, we have to define all the things based upon our requirement. Based upon our requirement. For example, let me go for taking as I am allowing complex content instead of defining empty. If I am saying that if it is empty, I won't write anything here. If I am saying that simple content, I am going to write one more element. I'm going to write one more element something. If I'm going to define the complex content, we have to define first. Let me allow whether I am going to define it as a sequence, choice, or all. For example, I'm going to define as a sequence. Then I have to use the tag called sequence. Sequence, the closing of sequence. Closing a sequence. Now I would like to define all the things. Element, something. Name of the element. Sorry, I would like to define clearly. Name equal to something. Type as what type? Element, name something, type as something. Element, name as something, type as something. Type as something. Yes. Now if you are going to write some XML file, what does that sequence means? Sequence means, for example, so this is the root node. It contains the 3 child elements. Yes. These 3 child elements has to appear in this XML file. That is the meaning of sequence, and has to appear along with the order. Has to appear along with the order. If in place of this sequence, if I am going to write as choice, out of these 3 elements, it has to write only one element. If you are going to write as all, it has to allow all child elements. But there should be no order. We can write in any order. We can write it in any order. Okay.